In addition to comparing strings, we can also use the is=to method to compare numerical values. So here we have this simple calculator class, and it's got a few methods here. We've got an addInts method, which adds two ints and returns an int. We've also got an addDoubles method here, which takes two doubles and returns the sum of two doubles. And we've also got this divide method, which we'll be looking at later in this module when we look at exception handling. So let's have a look at some tests. So here we've got a simple shouldAddInts test, and we're calling the addInts method and adding 1 and 2 together here, so we expect the value to be 3. So let's run this, and it passes as we expect it to. So that's using is=to and specifying an integer value. Let's see what happens when we use floating point values. So here I'm using the addDoubles method instead, and we're adding the values 1.1 and 2.2. So we're saying we expect a value to be equal to 3.3. But let's run this and see what happens. Notice here that our test has failed when it seems like it should have passed. Because we're using floating point numbers here, we can see the expected was 3.29999, etc. We can also see the actual value here, 3.3000, etc. So because we're using floating point values, we're not always going to get an exact value here. So with NUnit, we can add a call to the within method. And the within method will allow us to specify a tolerance for our equal to. So here we're saying that we expect the result to be equal to 3.3, but we're going to allow a tolerance of plus or minus 0.01. So now if the result is between 3.29 and 3.31, this test should pass. So let's run this, and we can see that our test passes now. In addition to specifying an actual tolerance value here, we can also specify it as a percentage. So in this example, we're adding the values 50 and 50, so we should get 100 back. But notice the assert here, we're saying it is equal to 101, which is clearly wrong. But because we're using the within method here, and we're specifying a value of 1, followed by the %, we're saying that the tolerance here is 1%. So even though we're going to get 100 back, because our tolerance here is 1%, this test will actually pass. So let's check this. And the test passes. Even though the value we've got back is 100, we've specified a percentage tolerance here. One thing to be careful of when using the within method is to be careful that we don't actually get passing tests when we should get failing tests, because of incorrectly specified tolerance values. So here we're adding the values 1.1 and 2.2, but notice this assert with checking that it's equal to 30 is clearly wrong. But because we've also made a mistake with our tolerance here, this means that the actual result can be anywhere from -70 to 130. So if we run this now, even though this test is wrong, the test will still pass. So it's always worth double checking the tolerance values that we use when we use the within method. When we're working with numeric values, in addition to using the is.equal_to method, there's a number of other useful shortcuts we can use. One of these is is.positive. So rather than using is.equal_to and specifying a value, we can say is the number positive. Similarly, we can specify is.negative instead of is.equal_to. And if we want to check that a number is not a number, we can use the is.nan.